In this video, I would like to use what we know about trigonometry to solve trigonometric equations. We'll start with linear equations and we'll build up from there in the next couple of videos. First, I want to highlight a difference between an identity and an equation. We've already seen a number of trigonometric identities or formulas. We need to remember those are true for all values of an angle theta, while trig equations are true for specific values of an angle, or in some cases for no values of an angle. And also, since trigonometric functions are periodic, the solutions to a trig equation will reoccur every pi or 2 pi radians. Every pi radians if it involves a tangent function, 2 pi radians if it involves sine or cosine function. So we can talk about two different types of solutions. The general solution is all of the angle values, accounting for reoccurring values, every pi or 2 pi radians, that make the equation true. Where the principal solution is all the values on a given interval, typically that's chosen to be 0 to 2 pi, that fit the equation. We'll look at some examples of providing both types of solutions to our trig equations. Let's say I want to solve 2 sine theta minus 1 equals 0 on the interval 0 to 2 pi. So this means I'm going to give the principal solutions that lie within that interval. Just like I would begin an algebraic equation by solving for x, let's try to isolate here the trigonometric part of this equation. So I can say 2 sine of theta equals 1, and divide by 2, we have sine of theta equals 1/2. So to solve for theta, you're asking this question: what angle theta, or we should say angles, from 0 to 2 pi have a sine ratio of 1/2? This is the fact that we need to solve for theta. So it may help here to remember, as a trigonometry fact, sine of 30 degrees equals 1/2. So certainly 30 degrees is one of our solutions. But let's consider the whole unit circle, because we're looking for any solutions from 0 to 2 pi. One solution is found here. This is 30 degrees, or pi over 6 radians. The other solution is found in quadrant 2, where sine of theta is also positive. So an angle theta in quadrant 2 with a reference angle of 30 degrees will also have a sine value of 1/2. This angle is 150 degrees, or 5 pi over 6 radians. We typically give our solutions as radian measure, and so I'm going to say the solutions are pi over 6 and 5 pi over 6. Here are the angles on the unit circle that satisfy sine theta equals 1/2. So they are the solutions to our trigonometric equation. In a second example, we'll provide the general solutions for the square root of 2 cosine theta equals -1. This means cosine theta equals -1 over root 2, or if you rationalize this, its more familiar form is root 2 over 2. So the trigonometric fact that may help us here is that cosine of 45 degrees equals root 2 over 2. And we need to find all of the solutions, not just on the unit circle, but the infinite solutions that have a cosine measurement of -root 2 over 2. Let's begin with the solutions from 0 to 2 pi. Cosine is negative in quadrant 2 and in quadrant 3. these would both have a reference angle of 45 degrees. This angle, measured from the positive x-axis, is 3 pi over 4. This angle is 5 pi over 4. So we can say, as the solutions to our equation, cosine of theta equals negative root 2 over 2, theta equals 3 pi over 4, and also 5 pi over 4, and yet the solutions reoccur every 2 pi radians. If I advance by a factor of 2 pi, I have revolved the whole way around the circle and come back to the same terminal angle. So we're going to say 3 pi over 4 plus 2k pi and 5 pi over 4 plus 2k pi, where k is any integer. It could be 0, but it could also be 1, negative 1. Any multiple of 2 pi will give us a coterminal angle that is also a solution to this equation. Here are the general solutions to our trig equation. Finally, let's solve tangent theta plus 1 equals 0. So we need to find all the angles of which it is true that tan theta equals negative 1. Now it may help to remember the trig fact here that tangent of 45 degrees equals 1. And so where on the unit circle will we see a negative tangent? That will be in quadrants 2 and 4. These would have a reference angle of 45 degrees. This is 3 pi over 4, and this is 7 pi over 4. Now one thing that we will notice here is for tangent, the period repeats every pi units. So I could simplify this answer by noting that they are exactly pi units apart from one another on the unit circle, and every time I advance or subtract another multiple of pi units, I will be back at one of these two terminal points. So I'm going to just take the initial value of theta equals 3 pi over 4 plus k pi. And once again, k is any integer. If I start at 3 pi over 4 and I add or subtract any multiple of pi, I will either be here or here with my coterminal angles. And that accounts for all the solutions of theta.